question says, use absolute value to determine the distance between each pair of numbers on a number line. Sketch a number line to illustrate the solution. So, what I'm going to do is I'm going to start with something a lot simpler that you could do in your head. So if I had the two numbers, so I'm going to just do this as a pre-example. If I said, what's the distance between 3 and 8? You would say right away that the distance is 5. And that would not be hard for you at all. You could see it right away that the distance is 5. If I said, well, how did you figure out 5? You'd be like, roll your eyes a little bit at your teacher, right? And be like, this is really easy. I just did 8 minus 3. That's what you would tell them, okay? But what they want to show you with the absolute value is that what happens if someone subtracted them in the wrong order? Like if I do 8 minus 3, I get 5. But if I do 3 minus 8, I get negative 5, which is not the right answer, because the distance between them is 5. Whenever I want to find the distance between things, it's always positive. And so if absolute value is distance from 0, when we use absolute value with numbers that we're subtracting, we're finding the distance in between them. Now, that's obviously 5, but what's cool about it is the distance between 8 and 3 is the same distance between 3 and 8. Because when you're measuring a distance, you're looking for how far apart are they. You're always saying positive number. So what's nice about the absolute value is, I mean, this would be absolute value negative 5. It's still 5. What's nice about this is sometimes our brain plays tricks on us. Like when you did 8 and 3, your brain obviously saw 8 was the bigger number and subtracted 3, the smaller number, to get 5. Okay? Your brain can play tricks on you, especially in A. If I say, which is the bigger number, negative 3.7 or negative 8.5? Which one's bigger?
3.7.
The negative 3.7. But 8.5 is a bigger number than 3.7. Can you see your brain kind of going, oh, you should pick the 8.5 one because that's a bigger number. But on the number line, negative 3.7 is further to the right and is a bigger number. But the nice thing about the absolute values is if you put the absolute value distance thing and you screw up which one's bigger and which one's smaller, you're still going to get the right answer. So technically, I should put the bigger one, negative 3.7, minus the smaller one, negative 8.5. Subtracting a negative is the same as adding, so what would I get here? Positive 4.8. And then the absolute value of that, of course, the distance is 4.8. So my absolute value bars here are saying I'm finding a distance. Mathematically, once you get a single number, it makes it positive. Okay? Important that if you want to use that shortcut of absolute values make numbers positive, that's only true once you've got a single number. I can't just change all of these negative signs to positives right at the beginning. Because if I change every negative into a positive, I will have 3.7 plus 8.5 and I will get the wrong answer. So it's important that if you're doing the fact that absolute value bars make numbers positive, that's only true once you have a single number in there. You can't change things to positives early. It'll cause mistakes. So that's an important little thing here. But we can just do this way. And I know you could draw it on the number line. Are you okay if we skip drawing number lines? Yeah. Okay. Ooh. B is like, can you review grade 9 fraction math? If I want to find the distance between these, so I want to find the distance between two numbers, 4 and 2/3, minus 5 and 3/5. minus a negative 5 3/5. And I picked the bigger one first, minus the smaller one. But if you accidentally screwed up and did it the other way, you will still get the right answers with the absolute value bars, because it'll find the distance either way. All right, let's review. This will be 4 2/3 plus, minus the negative is plus, 5 3/5. Couple of different ways of doing this. Okay, I'm going to go to like the standard way. It's going to have some bigger numbers, and then I'm going to show you a couple of other techniques as well. So probably the standard way to add these two together would be to change them to improper fractions. Okay, so I'm going to do standard way first. You see that this is 14 over 3 plus 25 plus 3, 28 over 5. And then I'm going to need a common denominator to add my fractions. So I need to multiply this one by 5 and 5, and this one by 3 and 3. Right? And I would get 5 times this would be 70 over 15 plus, and this will be over 15 as well. 3 28ths is going to be 84. And now that I have a common denominator, I get 154 over 15, or 10 4/15. That's the standard way that most people do fraction work. It's perfectly fine. It's great with mixed fractions. However, it had some big numbers, right? Like, how's your 14 times table? Is it like this, or did that 70 take a little bit of thinking? Probably took a little bit of thinking. Well, 28 times table? A little bit of thinking, okay? 4 2/3 means 4 2/3. Plus, I want to add 5 3/5. That means 5 3/5. For my second method, I'm going to make my life a little bit easier. I'm going to just add 4 plus 5 together and get 9. And I'm going to add these fractions together, but now my math is not quite as hard. Can you see that 2/3 is 10 over 15? And 3/5 is 9 over 15. So I would have 9 plus 19 over 15, which is 9 plus 1 and 4/15. And the 9 plus 1, that makes 10. So I have 10 and 4/15. And the biggest number here I had to deal with was, I got up to a 10 when I was multiplying. When I got up to a 19. That's pretty intense, I know. So sometimes we can do things in other ways to make our math numbers a little bit easier. I'm a math geek. I love math. So sometimes I do a question, and even though it's done, I look at it and go, I wonder if I could do this differently. And is the different method better, or is it worse? And then I find things that are faster or slower. Yes.
Can I take the 2 decimals?
You could take the 2 decimals. What do you mean by like? Without a calculator or with a calculator?
Like 4.6 repeating and negative 5.6.
Yes, you could do that, but then you would have to add those together with all those decimals repeated, and then change it back to a fraction in the end. Because often we'll want an exact answer. So it gets a little bit tricky that way. So fractions you'll find with exact answers a little bit easier. Okay, so you can circle questions on this one, 5 and 8, and I'll give you some time now to try